When solving quadratic equations, it's helpful to know the nature of the roots that you're going to be working with before you solve the problem. For example, if you're working with a real-world situation, you don't need any solutions that would be imaginary. The discriminant comes from the quadratic formula. Remember, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. The discriminant is going to be the radicand of this radical. So if we look at just b squared minus 4ac, that's going to tell us what type of solutions we're going to get. So if we think about a radical, well, there's several things that could happen. This number, when we simplify it, could be greater than 0. This number, b squared minus 4ac, could be less than 0. And this b squared minus 4ac could equal 0. Those are the only three things that could happen. If it's greater than 0, we say that it has two real roots or solutions. If it's less than 0, we have two imaginary solutions or roots. And if it's equal to 0, we have one real root or solution. Now, why do I know that we're going to have two real roots, two imaginary, or one real? Well, remember, this is coming from that radical. If we take the square root of a positive number, then we can have two numbers to equal it. If we take and have it less than 0, so that means it's going to be a negative number, we know if we take the square root of a negative number, then we're going to have to bring out an I. And whenever we work with an I, we have two imaginary roots. If it's equal to 0, we know that the square root of 0 is going to be 0, so we simply have negative b plus or minus a 0. And if we add or subtract 0, we're going to simply get that negative b, so we get one solution. So that's why we know how many roots and what type of roots they're going to be. So let's go ahead and look at an example of a quadratic equation and figure out what type of roots it's going to have to start. So I'll give you 3x squared plus 4x plus 7 equal to 0. Notice I'm already equal to 0, so I can use my quadratic formula. If it's not equal to 0, we need to make sure that it does. So we're going to simply look at this b squared minus 4ac. Remembering the first term coefficient is a, the second term's coefficient is b, and the third coefficient is c. Our b squared, in this case, is 16 minus 4 times a, which is 3, times 7, which is our c value. So we have 16 minus, we have 4 times 3, which is 12, times 7, which gives us 84. Now, without even working this out, we know that 16 minus 84 is going to be less than 0. So we know that this is going to have two imaginary roots. Let's go ahead and look at example 2, another quadratic, 2x squared minus x minus 4 equal to 0. Again, if I want to know the nature of our roots, I can simply look at b squared minus 4ac. B squared, we have negative 1 squared, so we have 1 minus 4 times a, which is 2, times negative 4, which is c. So we have 1, a negative 4 times 2 is negative 8, times negative 4 is a positive 32. So again, without having to work this out, I know this is greater than 0. So if it's greater than 0, we know that we are going to have 2 real roots. And let's look at one last example, example 3, just because we can. Let's say x squared plus 2x plus 1 equal to 0. So if I look at my b squared minus 4ac, b squared is going to be 4, because we have 2 squared, minus 4 times 1 times our c, which is 1. So we have 4 minus 4, which is equal to 0. So from what we had discussed earlier, if it's equal to 0, we have 1 real root.